So welcome to this video. We'll be going over the Cambridge International A-Level Maths October-November 2022 Pure 1 Paper 1 Variant 2. Let's go. Okay, so question 1. Okay, we have points A and B have coordinates 5, 2 and 10 minus 1 respectively. Find the equation of the perpendicular bisector of AB. Okay, so effectively, let's say we have a point here, which is 5, 2, okay. And we have another point, let's say here, which is 10 minus 1. If we join these up like this, okay, then what we want to do is find out the perpendicular bisector. So if I use purple now, that would be at a right angle to that line. It'd be perpendicular to that line. Effectively, we just want to find out what the equation of this line would be here. And to do that, it's fairly simple, okay? Two things we need to work out is we need to work out the midpoint of line AB, and then also work out the perpendicular gradient, okay? And then we can work out that equation of the line. So for me, that'll be the equation of that purple line, okay? So fairly simple. If we work out the gradient first, well, that'll be changing y with changing x. So it would be so m would be a 2 minus a minus 1 over a 5 minus a 10. So that will give me 2 plus 1, so we get a 3 over a minus 5, okay, which is just simply going to be a minus 3 over 5. So we know that our normal gradient, okay, we know that, not normal, but like this gradient here is minus 3 over 5, which makes sense, okay, because it should be a negative. Okay, and now we know that the perpendicular of that gradient would be the negative reciprocal. So therefore, if we call this one n, that would be a positive 5 over 3. Okay, so worked out that this gradient here is going to be a 5 over 3. Now what we can do, or what we need to do, is we need to work out what this point here. So that would be the midpoint, okay? This would be the midpoint now of line AB. So to do that, just work out the midpoint. So we know that it will be 5 plus 10 over 2. So that gives me a 15 over 2. So we know 15 over 2, that's the x value. And the other value, okay, well, again, that would just be a 2. And then we minus a 1, okay, and then 2. And then that gives us a half, okay? The same thing, you just work out the midpoint of those values, okay? So now we know that this point here, this would be a 15 over 2 or 7.5 and a half. And then now we can just use the equation of a straight line. Let's call this one n actually, because it's the perpendicular gradient. And we use the points where x is going to be a 15 over 2. We know y, that is going to be a half. And we know in this case our n value is going to be a 5 over 3. Okay, and then we need to write an equation for it. So that'll just be a y, take away a half, and that is equal to a 5 over 3 x minus a 15 over 2, and we can leave our answer like that. So now we have question B. Okay, question B is now find the equation of the circle center A which passes through B. So again, so now we have 5, 2, okay. But we know that 5, 2 is now the center, and now 10 minus 1, that is a point on the circle. So now, if I draw this line here, now what this line represents is, it represents the radius, okay? This is now going to be the radius. So, fairly simple to work out. We know the equation of a circle is going to be x minus a squared plus y minus b squared is equal to r squared. Now we know what our a and b values are. They're going to be, a is going to be 5 and b is going to be 2, because in this case, a is the center of this circle. All we now need to do is work out our radius. So to work out our radius, well, we know that we have this r value here, okay? So all we need to do is work out the length, okay? Just need to work out the length of this, and that will give us our value, okay? So, for example, what do we have here? Well, in our x direction, we have 5 and 10, so that has a difference of 5. and in our y value we have minus 1 and 2, so that's a difference of 3. So therefore, look at the length, it would just be a 5 squared, okay, plus a 3 squared, and that is all going to be square rooted, okay. So we know it's root of 34, but then again, we want to keep it in r squared, so therefore we know that while r is root 34, r squared is just going to be 34. And therefore, we can write the equation of a circle, so it will just be x minus a, that's the x coordinate of the center, which is 5. So x minus 5 squared, plus y minus the y coordinate of the center, so that's 2 for us. So y minus 2 squared, and that's equal to r squared, which we know is just 34. So, yeah, x minus 5 squared plus y minus 2 squared is equal to 34. For question 2, we have that the first, second, and third terms of an arithmetic progression are a, 2a, and a squared respectively, where a is a positive constant. Find the sum of the first 50 terms of this progression, okay? So if we have an arithmetic progression, okay, we have a, then we have 2a, and then we have a squared. And we know that because it's an arithmetic progression, okay, we know that we have a common difference, so we plus d each time, and that gives us our next value. If we try and write an expression now for this, well, then that means that a plus d must equal 2a. We also know that 2a plus d must equal a squared, okay? So if we want to get an expression for this, well, what can we do here? Well, if we label this one equation 1 and equation 2, well, with equation 1, okay, what we can do is we can actually, if we move the a to the side, then we get d is just equal to a, okay? Because we get d is equal to 2a minus a. So now we have d is equal to a. And now we can use that and we can put that into our equation now, and we can get an expression for a, okay? So if we so now if this is equation 1, now if we think about equation 2, if we put that value in for a for d, so we get a 2a, now we get a plus a is equal to a squared, okay? That gives me a 3a is equal to a squared. Bring everything to the same side, let's bring everything to the right side, so we get 0 is equal to an a squared minus a 3a, okay, and therefore we get 0 is equal to, if we factorize, a, and then an a minus 3. So this tells us that a is 0 or 3. Now we know in the question they tell us that a is a positive constant, okay? Therefore, we know that a cannot be 0, so we can just disregard this. So we know a is 3, okay? So now we know that a is 3. And if we know that a is 3, we actually also know that d is also going to be 3, okay? Because remember that over here, we have that a is equal to d. So now we've got a is 3, and we've also got that d is also 3. So now what we need to do is we need to work out the sum of the first 50 terms of the progression, which we can now do, okay? Because the sum, if I write it here, the sum of an arithmetic progression is n over 2 times a1 plus n minus 1d, okay? And we know what n is, okay? We know that n is going to be 50, because we want the sum of the first 50 terms of the progression. Okay, we also know that d is a 3. And for that a1 term, what's our first term? Well, our first term was, again, just a. So we know a is 3, therefore this means that a is also going to be 3, or a1 is going to be 3. And now we just put this into the formula, and that should give us our answer. So if we do that, we know that S50 is equal to 50 over 2, so that's 25. That is 2 times 3, which is going to be a 6, plus n minus 1, so 50 minus 1, so that's 49. And that's also going to be times by a 3, okay? And then if we just work this out, well, we get a 25, okay? And then we get a 6. Now, 49 times 3 is 147. So we get 6 plus 147, which gives us a 25 times 153. If you work that out on your calculator, you will get a 3,825. 3a, find the set of values of k for which the equation ax squared plus kx plus 2 has no real roots. So what that means, if something has no real roots, then the discriminant b squared minus 4ac must be less than 0. So in our case, we have that a is equal to 8, we have b is equal to k, and we have c is equal to 2. Therefore, b squared will be a k squared, okay, minus a 4 times an 8 times a 2, which is 64. That is less than 0, okay, and therefore we would get a k plus 8, and we would also get a k minus 8 because the difference of two squares. So that is also going to be less than 0. So therefore we have k is equal to minus 8, and we have k is equal to 8. And now if I just draw a little diagram here, now we see when will that be less than 0. So think about the quadratic graph for this. Well, k squared minus 64, okay, that's going to be a U-shaped quadratic graph, okay, and it's going to cut at minus 64. So it's going to look something like this, okay. So now that we've done that, we know that this point here, that is going to be the minus 8. This point here, that will be the 8. We want it when it's less than 0, so it's just going to be all of these values here. Therefore, for our answer, we know that our answer will be minus 8, which is less than k, which is less than 8. So pretty much all values between minus 8 and 8, if k is a value between minus 8 and 8, therefore it will have no real roots. So now for part B, we have to solve the equation 8 cosine squared theta minus 10 cosine theta plus 2 is equal to 0, where theta is between 0 and 180. The first thing I'm going to do is I'm going to use substitution. I'm going to let y equal cos theta. So now we have that 8y squared minus 10y plus 2 is equal to 0. And now I'm going to factorize this. So what I'm going to do is, if we do 8 times 2, that is 16, okay? So now I'm thinking of two values which can sum to make a minus 10, multiply to make a positive 16. So that would be a minus 8 and a minus 2. So therefore, this minus 10y splits into a minus 8y and a minus 2y. I'm going to factorize these two separately now. So I'm going to factorize the 8y squared minus 8y first, which gives me an 8y, then a y minus 1. So therefore, we know that we should get a y minus 1 over this side. And when I factorize the minus 2y and the 2, well, that would simply just be a minus 2 on the outside. So therefore, when we factorize it, we get an 8y minus 2 and a y minus 1. That must, in our case, that must equal 0. So therefore, we get a y as a 2 over 8, which is a quarter. So we get y as a quarter. We also get y as 1. And then remember we use substitution. So now we've put back in cosine theta. So we get cosine theta is equal to a quarter. And we get cosine theta is equal to 1. Okay, so now that we've got this, I'm going to draw a cast diagram over here. So I'm going to start with the cosine theta is equal to a quarter. So if I do that here, okay. Now, we know that it's positive, okay? Because we just have a positive a quarter, so we know that cos is going to be positive. So we're going to be in these two regions here, okay? And if you do the inverse cos of a quarter in your calculator, you will get 75.5. So we get a 75.5 here, and we get another 75.5 here, okay? And then for cos theta is equal to 1, I would say for ones like this, where it's going to be like an exact value like that, if you're ever unsure, again, you can just put it into your calculator, which will give you 0. But if you're unsure whether that's going to repeat, you can also just use the cos graph as well. If you remember what the cos graph is, okay, you can use the cos graph here. So I'll do it for you here. So the cos graph, it goes in like this shape here, like this. And this point here, so that's on the y coordinate is 1. And then this point here, that would be 90 degrees. The minimum, that would be 180. This would be 270, and then so on. And then the y, the minimum would be a minus 1 here. You can also draw the graph as well. And yeah, this is going to be 0. And we can just double check that cos theta doesn't, because remember we're dealing with cos theta between 0 and 180. So you can also look at the graph and look at does it have any other values at 1 between 0 and 180? Well, it only has this one value here. It has this one value here when it's at 0 degrees, okay? And then again, it would repeat, but it would repeat at 360, but that is not in our limits, okay? So therefore, we know that if we look at the cos graph, we know that theta, okay, theta, it will be 0 degrees for one of them, okay? And that's just a cos graph. We only get 0. And then for the cast diagram, well, again, we want it between 0 and 180, so that would be up here, and then we'd stop here. So therefore, we only have one value, which would be 75.5. Therefore, theta is 0 degrees and 75.5 degrees. Okay, question 4. Okay, we've got a geometric progression is such that the third term is 1,764, and the sum of the second and third terms is 3,444. We need to find the 50th term, okay? So we need to find A50. So what do we know? We know that A3, okay, the third term is 1,764. We know the sum of the second and third terms is 3,444. So we know that A2 plus A3, that must equal 3,444. And we know what A3 is. Okay, tell us that in the questions. So we can work out A2. We know A2 plus 1,764 must equal 3,444. Therefore, we know that A2 is equal, if we work that out, we know A2 is equal to a 1,680, okay? Just be careful of that one, okay? It does say the sum of the second and third terms is equal to 3,444. So be careful not to get confused with the geometric and multiplying and stuff. Just be wary of that little part, okay? But now we've worked out what the A2 term is, okay? Now we can actually work out what our R value is. Because now, if we think about the R value, well, we have an A1, which we haven't worked out yet. We know A2 is 1,680, and we know A3 is going to be a 1,764. And we know if we're dealing with a geometric progression, we know that we're going to multiply by some value R, and that will give us our values, okay? So if we know the second and third term, we can actually work out what our value is straight away. If we just do 1,764 divided by 1,680, if you do it in your calculators, you will get exactly 1.05. So we know that our R value is 1.05. We're multiplying by 1.05 each time, okay? So now we know that, we can actually work out our A1 value now. Our A1 value would simply just have to be a 1,680, okay? And what we would do to get that is that will be divided by our R value, okay? Because our R value, that will give us what A1 value is. So we can just divide by our R value, which is 1.05. And if you work that value on your calculator, you get a 1,600, okay? So now we know our A1 value is 1,600, okay? So now works out that our A1 value is 1,600. Well, if we look at the 50th term, well, the general solution is AN is equal to A1 times by R to the power of n minus 1. That is a general formula to work out any term in a geometric sequence, okay? So we can just use this now to work out a 50 term. So that would be A50 is equal to A1 times by R. So, yeah, times by R. And then for us, that will be 50 minus 1. So that will be R to the power of 49. So therefore, for us, that will be A1, which we know is 1,600, times by R, which we know is 1.05. And that'll be to the power of 49, okay? And then if you were to put that into calculator, we would get the answer of 17,474.121 dp, and that would be our answer, okay? Question 5, we've got the graph of equation y equals f of x is transformed to the graph of equation y equals g of x by a stretch in the x direction with factor 0.5, followed by a translation of 0, 1. The diagram below shows the graph of y equals f of x. On the diagram, sketch the graph of y equals g of x, okay? So for this one, fairly nice. We've got two transformations happening. We've got the scale factor in the x direction and the translation of 0, 1. So first thing first, let's think about the stretch in the x direction, okay, with factor 0.5. So what does that mean? That means that for our graph here, everything is going to be like squished in half. So we're still going to have the same, I guess, properties, but it's just going to be half the size, okay? So in that case, as you can see, we're going from 0 to 4. Now this whole graph will be just going from 0 to 2, okay? So that's the first thing I'm going to do. So to do that, it will be like this. So everything has been squished in half like that, okay? And then with that, that is the scale factor of 0.5 done. Now we need to think about the translation of 0,1. So what does a translation of 0,1 mean? That means everything is being shifted up by 1 unit. So again, as we see, we need to shift everything up by 1 unit. So this, for example, will now go to 2. And then this bit will now go to 4, for example. So now that's what I'm going to do. I'm going to shift everything up by 1 unit, okay? And if I do that, we end up being right here, okay? And that would be what the graph would be, okay? Okay, part B, we need to find an expression now for g of x in terms of f of x. So pretty much, what are we doing to f of x to get it to g of x? Well, we know it's a stretch in the scale factor on the x direction by half. So that would be f of 2x, okay? Remember, when we have a stretch in the x direction, okay, it's always going to be the reciprocal is what we write down. So f of 2 of x. Then it was a translation of 0, 1. So we're shifting up by 1 unit. So that would just give us a plus 1. And yeah, that is it. So g of x would just be f of 2x plus 1. Okay, for this question, we have the equation of a curve is y equals 4x squared plus 20x plus 6. We need to express the equation in the form of y equals a times x plus b all squared plus c, where a, b, and c are constants. So effectively, we need to complete the square. So if we think about completing the square for this, therefore, what do we get? So we get a 4, and then if I open the brackets, we get an x squared plus a 5x, okay? And then we would get plus a 3 over 2, okay? So now we've got that. Now if we just complete the square now, so we get a 4, then in brackets we'll get an x plus a 5 over 2, and that'll be all squared, minus a 25 over 4, plus a 3 over 2. So we get a 4, and then x plus a 5 over 2 squared, okay? And then this one will be a minus 25 over 4 plus a 6 over 4. So therefore we get a 4x plus 5 over 2 squared, and that will be a minus a 19 over 4. And then if we just multiply out by 4 now, we get a 4, and then in brackets x plus 5 over 2 squared minus 19, okay? For part B now, we need to solve this equation of 4x squared plus 20x plus 6 is equal to 45. So what we can do is we can use what we just did in the previous question, okay? So in the previous question, we got that 4x plus 5 over 2 squared minus 19. And yeah, we can effectively replace that with the 4x squared plus 20x plus 6. So if we keep that there, that must be equal to a 45. So therefore we get a 4, and then in brackets x plus 5 over 2 squared, that must equal a 64. And therefore divide by 4 on both sides, so we get x plus 5 over 2 squared, that is equal to a 16. And now if we square root both sides, we get x plus 5 over 2, that is equal to a plus or minus the square root of 16, which is 4. And now we get two values, so we get either x is equal to a minus 5 over 2 minus 4, or x is a minus 5 over 2 plus 4. Therefore, our x value, okay, that would be x is equal to a minus 4, that will give me a minus 8 over 2, so that will give me a minus 13 over 2. And then for the other one, we would get a positive 3 over 2. So for part C, we need to sketch the graph of y equals 4x squared plus 20x plus 6, showing the coordinates of the stationary point. So going back to part A, we know that y is equal to a 4, then in brackets x plus 5 over 2 squared minus 19. So why is this significant, okay? Well, it's significant because actually we have a lot of information here. If you go back to maybe your GCSE days, you've probably seen this before where we can actually work out the minimum and maximum points when we complete the square, right? Because we know that this value here, this minus 19, that is going to be the minimum y value, right? This is the minimum height, this minus 19. And here the x coordinate, well, x plus 5 over 2, if we make that into 0, right, then we get x is just 5 minus 5 over 2, okay? So we know this, we know that will give us our x coordinate of the stationary point. So actually we know that the stationary point for this is actually just going to be a minus 5 over 2 and minus 19. So therefore, drawing this graph now becomes fairly simple. We know the coordinate of the stationary point, so we can get a general gist of what it should look like. So if I draw the graph here, well, we know that it's going to be the normal positive quadratic graph in that U shape. We know that it's going to have a stationary point in minus 5 over 2, minus 19, which means that both x and y are going to be negative. So we should get a stationary point in this region here, this quadrant here. We also know that we don't need to put this on our graph, but we know that it cuts the y-axis at 6, okay? Because if we make x 0, we just left with y equals 6. So we know that it's going to cut the y-axis somewhere over here. So using that, we can think of a general base for this shape, and it would look something like this, okay? Something like that, okay? And that is perfectly fine. And what we can do is we can say that this, because this is the minimum point, this would be minus 5 over 2 minus 19. And that looks fairly right because it's in the right quadrant. We have a positive graph. And even here, we don't need to include this, but we know this would also be a 6 as well, which is perfect for us. So everything looks right. And yeah, we can leave it like that. So we've sketched the graph. We've shown the course of the stationary point. And yeah, that should be enough for the marks. Okay, question 7a now. We need to prove the identity sine theta over sine theta plus cosine theta plus cos theta over sine theta minus cos theta is equal to tan squared theta plus 1 over tan squared theta minus 1. Okay, so what I'm going to do is I'm just going to multiply by denominator, cross multiply, and then let's see what happens, okay? So if I do that, we get a sine theta. So that would be a sine theta minus a cos theta. Okay, and then we get a plus cos theta times by a sine theta plus cos theta. And that would be all over a single fraction now of a sine theta plus cos theta times by a sine theta minus a cos theta. Okay, so if we multiply this out, we get a sine squared theta minus a sine theta cos theta plus a sine theta cos theta plus a cos squared theta, okay? And that would be all over, well, this would give me a difference of 2 squares. So this would be a sine squared theta minus a cos squared theta. Okay, and now as you can see here, okay, this and this would cancel out, so we're left with a sine squared theta plus cos squared theta, and that is over a sine squared theta minus cos squared theta. So now what can we do now to work this out? Because in our question, we have tan squared thetas, okay? And this can get a bit more complicated. But because we know we want to get tans, well, let's try and formulate an equation with tans, okay? So we know that from our identities, we know that sine theta over a cos theta is equal to a tan theta, okay? We also know as well by that reasoning, we actually also know that a sine squared theta over a cos squared theta is also equal to a tan squared theta, okay? So now that we know that, what we can also do is if we multiply by that cos theta, we actually know that sine squared theta is equal to a tan squared theta times a cosine squared theta. So now we've got that. Well, now we have an expression now for sine squared theta in terms of tan squared theta and cos squared theta. So now let's replace our sine squared theta for that value, okay? So if I do that here, we get a sine squared theta. So now that becomes a tan squared theta cos squared theta plus a cos squared theta. And then that is equal to another tan squared theta cos squared theta minus a cos squared theta. And therefore, if we just factorize now, well, if we factorize this, we would get a cos squared theta, and then in brackets, a tan squared theta plus 1. We'll change it plus 1, and then our denominator would be another cos squared theta, and then a tan squared theta minus a 1. And as you can see, coses cancel out, and we're just left with tan squared theta plus 1, and that is over a tan squared theta minus 1. Okay, so now we now need to work out the solutions to that equation where it's equal to 2 and where theta is between 0 and pi, okay? So to do that one, well, we know that a tan squared theta plus 1 over a tan squared theta minus 1, that equals 2. Okay, so we can just rearrange this, and then, yeah, we can work it out. So if we multiply by tan squared theta minus 1 to both sides, we get a tan squared theta plus 1 is equal to a 2 tan squared theta minus a 2. Okay, and if we bring everything to the right side, okay, what do we get? Actually, no, let's bring the tan squared theta to the right side. Let's bring the minus 2 to the side. So we get a 3 is equal to a tan squared theta like this. And if we just rewrite this, tan squared theta is equal to 3. And therefore, if we get rid of that square root, if we go to the square, so we square root, we get a tan theta that's equal to plus or minus the square root of 3. So we get tan theta is equal to this plus or minus the square root of 3. So now when I look at my cast diagram now, I'll draw my cast diagram over here. And when I think about my cast diagram, right, we are going to be in every single quadrant, okay? Because we want to consider when tan is positive but also negative, okay? So we're going to be in every single quadrant, okay? So now if you do the inverse tan of root 3 in your calculator, make sure you're in radians as well, you will get a pi over 3. So we know that we're going to have a pi over 3 here, we're going to have a pi over 3 here, another pi over 3 here, and another pi over 3 here. So remember, we're going to be in all quadrants because we get a plus or minus root 3. We have a positive value for tan, we have a negative value for tan. Okay, and now in the question, we want it between 0 and pi. That's what they state. So therefore, between 0 and pi is just going to be this, like this bit here, only half of the region. So we get a pi over 3 as one of our values, okay? So we get theta being a pi over 3 as one of our values, and the other value would just be this value. I don't know what I call it. It'd be like this value here. So that's going to be a pi take away a pi over 3, which will be a 2 pi over 3. Okay, so those are our two values. Okay, we have this value here, and we also have this value here. Okay, so pi over 3 and 2 pi over 3. Okay, for this question, we have the equation of a curve is such that dy by dx is 3x to the power of a half minus 3x to the power of minus half. The curve passes through the point 3,5. Find the equation of the curve. Okay, so what we do is integrate and then find our constant value, and that should be our answer. So if we start integrating this, we would get a 3x to the power of 3 over 2, and that will be over a 3 over 2. And then we get a minus a 3x, that would be to the positive half, and that will be divided by a half, okay? And then we get a plus c, so therefore y would equal, so we get a 3 divided by 3 over 2, okay? So that will give us a 2x to the 3 over 2, and then for this one here, we would get minus a 6x to the half plus c, okay? And now we know that we want it when it crosses through 3 and 5. Okay, so now we just put in those values of 3 and 5 to get our value of c. So that'll be a 5 is equal to 2 times a 3, okay, to the power of 3 over 2, and that'll be minus a 6 to the 3 to the power of a half plus a c. So for this one, we get a 5 is equal to a 2. And this one seems a bit difficult because it won't give us a nice number, okay? But what we can do is effectively two ways we can think of it. We can either square root it first, so we get the square root of 3, and then we multiply it by 3. Or maybe I think the easier way is we raise the power of 3 first, so we get 27, and then we square root. So we get 2 times the square root of 27, and I'll tell you why that's easy in a second. And then we get 3 to the power of a half, which let's just keep it as root 3, so minus 6 root 3 plus c. And now with the root of 27, so we get a 2 here. If we write the root of 27 in third form, okay, we actually get a 3 root 3, okay? If we write it in third form, we get a 3 root 3. And then we also have a minus 6 root 3 here, and that's plus c. And therefore, they actually cancel out because we end up with a 6 root 3 minus a 6 root 3 plus c. So then the 6 root 3 cancels out with the minus 6 root 3. And we're just left with c being 5, okay? And if we know c is 5, well then we know what the equation is, because obviously we know that this was what our y is, so we just put it back into that equation here. So therefore, we know that y is equal to a 2x to the 3 over 2 minus a 6x to the half plus our c value, which we now know is 5. So for part B, okay, we need to find the x-coordinate of the stationary point. Now, for this question here, okay, they give us dy over dx is 3x to the power of a half minus 3x to the power of minus half. And we know to find the stationary point, we need to make dy over dx equal to 0. So that's what I'm going to do here. So we have 0 is equal to 3x to the half minus a 3x to the minus half. Okay, I'm going to bring that 3x to the minus 3x, so we get a 3x, and that is equal to a half, okay, and equal minus a half, and then we get 3x equal to a half on this side. Now we can get rid of 1 because we get rid of 3 because 3 is in both, so we're left with x is equal to minus a half, and that's equal to x is equal to a half. Okay, and now we have to figure out, okay, what could we possibly have here, okay? What value could we possibly have where it would have to equal the same thing, okay? So if we think about it this way, there's only actually one value we can get, and that is actually x is equal to 1. That's the only value which will satisfy this. And if you're not sure about that, then you can go a step further, okay? You can actually square both sides. So if we square both sides, we get a squared here, and then we get a squared here. And then you'd get x to the minus 1 on this side is equal to x. So we get 1 over x is equal to x. And now you're thinking, oh, well, actually, if we do 1, we get 1 is equal to x squared, right? So if we write this like this. But then that is plus or minus 1. So actually, we get a minus 1 as well. But we don't. The reason we don't get a minus 1 is because remember at this stage here, okay? If we look at this stage here, okay? We look at that stage here, we can't get that. It doesn't work because if we take this stage out, if we try and put minus 1 into this, okay, we get minus a half, and then that's equal to minus 1, and then that is also a half, right? We can't square root a negative number. So it's just invalid. It's an extraneous solution. You can think of it like an extraneous solution. Therefore, it actually doesn't work out. We can't do anything like that, okay? Because we know that that is just not a valid solution. Therefore, that's why we can't take minus 1. But therefore, as a result, our answer is simply just going to be x is equal to 1. So for part C, we need to state the set of values of x for which y increases as x increases, okay? So what I would do for this one is, maybe you can tell if it's a minimum or maximum point straight away, but what we need to figure out is that x equal to 1, is that going to be a minimum point or a maximum point? Because that will help us determine what the set of values are for which it increases. So while we can look at this, and because it says for which y increases as x increases, we can safely say that x equal to 1 is a minimum point. But there could be a situation where you have maybe a harder question and you're not given as much information. So I'm just going to show you quickly what I would do in that scenario, and I'll base it using this question. So what I would do first is, if we work out f dash dash x, okay, so the second derivative, if the second derivative of x at that stationary point is greater than 0, therefore we know that it's going to be a minimum point, okay? And we also know that if that second derivative is less than 0, it's going to be a maximum point, okay? So that is what I'm going to do now for this question. So if we work out f dash dash x, okay, if we work that out, what do you get? You get a 3 over 2 x to the minus a half, okay, plus a 3 over 2 x to the minus 3 over 2, okay? Now we put in our value of our stationary points. In this case, we put in 1. And what do you get? You get a 3 over 2 plus a 3 over 2, which is a 3. Therefore, this relates with this one here. It's going to be a minimum point. And if we know it's going to be a minimum point, then we know that that's the minimum point. If we know when x increases, y increases, well, if we think about normal quadratic graph, okay, if it's a minimum, it's going to be in the normal quadratic shape. You can think of it like that. Therefore, it's just going to be all values of x greater than 1. And if I just draw a little graph here just to show you what I mean, this is not like an accurate to scale graph. This is a random quadratic graph. Okay, let's do it over this side here. And if you consider that this point here is like -1 and then some y value, right? As you can see that when y increases as x increases, okay, it's always going to be values greater. Wait, if I put -1, that should be just a positive one. As you can see, as y increases, as x increases, it's always going to be a value when x is greater than 1. Therefore, you can just write for this question that x is greater than 1. Okay, so this one we have f of x and we have g of x. We need to find an expression for g of f of x. So g of f of x is simply just going to put whole f of x into the g of x. That'll just be a, and then that will be an x plus a 1 over x plus 1. And yeah, we are done with that question. So for part B now, okay, we have that g of f of 2 is 11. Find the value of a. So we know that if we work out f of 2 first, okay, f of 2 would be 2 plus a half, which is 5 over 2. And then if we ask that, that means that g of 5 over 2 must equal 11. So that was ax plus 1. So know that that would be an a 5 over 2 plus 1 must equal 11. Therefore, we know that a 5 over 2a must equal 10. Therefore, a must be a 10 divided by a 5 over 2. And that is equal to a 10 times a 2 over 5, which is a 20 over 5. So we know that a is simply going to be a 4. So part C now, we've got given that the graph of y equals f of x has a minimum point when x is equal to 1, explain whether or not f has an inverse, okay? So for something to have an inverse, it has to be a 1-to-1 mapping, okay? It has to be a 1-to-1 mapping. So for a normal quadratic equation, right, where x is like all real numbers, if we let that happen, that will never have an inverse, right? It needs to have a 1-to-1 mapping, okay? So if we want to explain whether or not f has an inverse, then well, what can we do? Well, we know that for f of x, it has a domain of when x is greater than 0, okay? So if we can find two values of x which share the same y coordinate, we know that it doesn't have an inverse. And so if I write, so f of x was x plus a 1 over x. If we can find two values of x which is greater than 0, which have this same value, then we know that that is not the case. And we can, because it's x plus 1 over x, so it's just a value plus its reciprocal. So for example, we can use 2.5. For example, if we have f of 2, well, f of 2 would be 2 plus a half, okay? That'll give me 5 over 2. If we use f of a half, that would be a half plus 1 over a half, which is 2, that would also give me a 5 over 2. Therefore, we have two x values going to the same y value. So therefore, we can say that something like this function is not one-to-one. Therefore, it does not have an inverse. Okay, so we can write something like that. So part D, we've got that a is now 5. Find and simplify an expression for g minus 1 f of x. Okay, so if we know that now a is 5, we have g of x is equal to a 5x plus 1. Now, we're going to find an equation for this. So with this one, all we do is find an inverse for g to the minus 1. So find an inverse of g of x first, and then once we get that, then just put f of x inside. So if we work out the inverse of g of x first, then if I rewrite this as x equal to 5y plus 1, and then that will be an x minus 1 is equal to a 5y. So we get y is equal to an x minus 1 over 5, okay? So therefore, we know that g of minus 1x is equal to an x minus 1 over 5. And now we can just put f of x into this. So our f of x, if I write that over here, f of x was x plus 1 over x. So therefore, for us, if we do g to the minus 1 of f of x, that would be x plus 1 over x minus 1. And that would be over 5. Okay? And if we just simplify this down a bit, we can get 1 over 5, okay, and that is equal to x plus 1 over x minus 1. So for part E now, we need to explain why the composite function fg cannot be formed. So if we think of f of g of x, okay, so if I rewrite what f of x was, we know that's going to be an x plus 1 over x. And in this case, we know that g of x is now going to be a 5x plus 1. Why can't we f of g of x be formed? Okay, so if we write what f of g of x is, okay, well, we know that f of g of x is the same as f of a 5x plus 1. And now what's important to know is, remember from part A, okay, we had these domains. So we have f of x has the domain of x is greater than 0, and g of x had the domain of x is can contain any real number. And that's important, okay? So because we know that, when we look at f of 5x plus 1, okay, then we know that all of that has to have the domain of 5x plus 1 is greater than 0, okay? So if we work this out, well, that will give us that x is greater than minus 1 over 5. So at first glance, you may think, oh, okay, well, what does that really mean? What this means is if x has to be greater than minus 1 over 5, the problem with this is because of g of x can contain any real number. If we put something into g of x, right, we can get a value of g of x, right, which is not going to be in this value. Because whatever value we get of g of x, right, it has to, like pretty much the range of g of x, whatever we get of g of x is going to be the domain of f of x, okay? So, for example, if we get g of minus 1, for example, right, because that's valid for g of x, right? If we put that in, so g of minus 1, so that would be into the 5x plus 1. That's a 5 times a minus 1 plus a 1. That gives me a minus 4. But then the problem with that is if we do that, so again, if I do f of g of minus 1, okay, that would give me f of minus 4. But we can't do f of minus 4 because that's not in our domain. Our domain, because of the f of x, right, our domain in this case has to be less than minus 1 over 5. But as you can see, because of the nature of g of x, and it contains all real numbers, when we put a value of f of g of minus 1 in, which is valid for g of x, right, we get minus 4, but we can't do f of minus 4 because x can only be greater than minus 1 over 5, which means that this is not valid at all. F of gx cannot be formed because the domain of f and the range of g, they're just all off, okay? They don't match each other. So therefore, because of the fact that we can't, every range, all the values of g of x, it does not match f of x, then yeah, it cannot be formed, okay? So then we can write something like, you can write something like, yeah, the domain of f, okay, does not lie in the whole range, okay, of g, okay? And yeah, that's it. It's one of the weird questions. There's only 1 mark. It's not the worst case if you don't know this, but again, it's not too bad once you understand. Okay, question 10. Okay, we have this diagram here, cross section RASB of an aircraft. We're told the cross section consists of a sector OARB, has a circle with radius 2.5 meters with center O. Sector PASB, another circle radius 2.24 with center P. The quadrilateral OAPB, angle OAB is 2 over 3 pi, angle APB is 5 over 6 pi. And we need to find the perimeter of the cross section RASB, given our answer to 2 decimal places. So we want to find the perimeter of all of this. So we're going to find, yeah, pretty much just all of this, RASB, so we're going to find what this perimeter is. Now, it looks very difficult. The shape is fairly odd, but it's actually not that bad, okay? We can actually use our normal equation to work this out. So, what do we know? Well, we know that the equation of an arc length is r theta, okay? Now, one thing we have to do, one small note, is this angle here, okay? We look at this angle, okay? Because right now we know that this is 2 over 3 pi. But actually, if we're looking at arc length for RAB or OARB, okay, it's actually going to be this angle we want, which is fine. We can actually work this angle out, okay? We can work out what the angle is because if you think of it, if we know that it's 2 over 3 pi, we know that it's that the other angle has to make, I guess, the circle, right? Make the angle into a circle kind of thing. So we know it's going to be 2 pi. So the total has to be 2 pi. We know that that angle just has to be 2 pi minus a 2 pi over 3. Okay? And then that is a 4 pi over 3. So now we know that this angle here is a 4 pi over 3. And if we know that, we can use the arc length formula. So arc length is equal to r times theta. We know that for OARB, okay, we know that the center is O and the radius is 2.5. So it's going to be 2.5 times by theta, which we now have worked out as 4 pi over 3. And if you work that out, 2.5 times 4 pi over 3, if we leave that in the exact form, we just get 10 pi over 3. So we know that all of this arc length, we know is 10 pi over 3. Okay, let me just write that here. We know this is 10 pi over 3. Now we need to work out PASB as well, because that will give us the arc length, that ASB line. So we need to work out this angle here, this length here, and again, fairly simple. Its length is equal to r theta. This case, we have theta as 5 pi over 6, which is actually what we want in this case, so we can leave it like that. We know the center for this one is 2.24, so therefore L is just 2.24 times by 5 pi over 6, okay? And you put it into a calculator, you get 28 pi over 15, and therefore, if we want to work this out, okay, do it down here, well then, if I write that this is 28 pi over 15, then what do we know? Well, again, we've worked out both arc lengths now. We've worked out the length of, let's call it ARB. We know this is a 10 pi over 3, and we know that ASB here is a 28 pi over 15. Just need to add them up now. So we add them up, we get a 10 pi over 3 plus 28 pi over 15, and that gives us the perimeter of 26 pi over 5. So part B now, we need to find the difference in the area of the two triangles AOB and APB, given your answer to two decimal places. So if I do it back on the graph here, for this question here, okay, fairly nice. If we have OAB here, so we look at AOB, so that's this triangle here. Okay, we just need to work out the area, and then also work out the area of triangle APB, so that's this one here, and then just take them away from each other. Okay, so fairly simple to work out actually. So we actually can just use a half AB sine C, okay, because we have two sides and the included angle for these. Obviously, we know it's radius, so we also know that this also would be a 2.5. We know that this will also be a 2.24 because they have the centers and they have the radiuses. They're going to be the same. Well, we're going to use a half AB sine C. So for AOB, that would just be a half times 2.5 times 2.5 times sine. And then again, for this one, got to be careful. It's now going to be the 2 pi over 3, okay? Because now we want the included angle within the triangle. So if we work that out on your calculators, you will get 25 root 3 over 16. And then we do the same thing for a PB, okay? So if we do that for that one, we would get a half times a 2.4 times a 2.4 times a sine of a 5 pi over 6, okay? And if you put that into your calculator, you will get a infraction from 784 over 625. And again, we want the difference, so same like the previous question, just do a 25 root 3 over 16 minus a 784 over 625 into your calculators, and then you will get to two decimal places 1.45. So for part C, we need to find the area of the cross section RASB, given our answer is correct to one decimal place. So RASB. So we want to find now the area of RASB. And at first glance, you may be like, what do we have to do? Because that is all of this. How to look at the area of all of this. Remember that it's just an arc. It's just an arc, effectively, right? It's just a bit of an odd shape. And we know the equation when we have an arc for the area of the arc. We know that it would be a half r squared theta, okay? So that's what we're going to do. We're going to work that out. And we can do that for our OARB. So we can work out the area of this arc here. And if we do that, that would simply just be, so for, if I write that here, OARB, okay, that will simply just be a half times r, which is 2.5 squared, and times theta, which is a 4 pi over 3. Okay, remember, it's a 4 pi over 3 when we're leading with the arc. And that will give me a 25 pi over 6. Okay, so now we just worked out the OARB. Okay, now we can work out the arc length, or the area of the arc of the PASB now. We can work out this one as well. So if we do that, so if I write that, that'll be PASB. So that will be a half times a 2.4 squared times by a 5 pi over 6. And you put it into a calculator, you will get a 784 pi, and that is over 375. So now we've worked out the area of this, and we've worked out the area of this. Okay, but as you can see, if you look at the quadrilateral OAPB, we have not worked that out yet. So how do we work that out? Well, in the previous question, we actually worked it out. Remember in the previous question, we had to work out the area of the triangles and take them away from each other. And by effectively doing that, we actually worked out the area of this without even realizing, which was 1.45. So actually, we actually know the area of everything. We know the area of this, we know the area of this, and we also know the area of this, which is our answer to part B. And now we can just add them all up together. So by doing that, we do a 25 pi over 6 plus a 784 pi over 375 plus the 1.45. And if you add all that up together to three significant figures or to one decimal place, you get 21.1. So this question means to find the coordinates of the minimum point of the curve of y equals 9 over 4 x squared minus 12x plus 18. So first thing first, we need to differentiate. So dy over dx, okay, what would that be? So if we do 9 over 4 times 2, that gives me 18 over 4. 18 over 4 simplified down as 9 over 2. So we get a 9 over 2x, okay, and minus a 12, and that would be it for dy over dx. And then for stationary point, we know that it's going to be a 0 is equal to a 9, x over 2 minus 12. Therefore, we get a 12 is equal to a 9x over 2. Therefore, we get a 24 is equal to 9x. So we get x is equal to a 24 over 9. So now x value is 24 over 9. And therefore, we just need to put back in that x value into the equation. Okay, so therefore we get a y is equal to a 9 over 4, 24 over 9 squared minus 12 times 24 over 9 plus 18. I put that into your calculator, you get 2. So therefore, our coordinates is simply just 24 over 9 and a 2, okay? So part B now, we have these two equations, two curves. We have y equals 18 minus 3 over 8x to the power of 5 over 2. We also have the y equals 9 over 4x squared minus 12x plus 18. And we need to find the area of the shaded region. So it tells us in the equation that the curves intersect at the point 0, 18. Okay, so we know that this is going to be 0, 18. We know that this is going to be a 4, 6. Okay, so because we know that, okay, what that tells me is if I just draw a little line here, we know that obviously this would be a 4 here, and then that's the origin here. And if we think about the area, let's think about if we're integrating just 18 minus 3 over 8x to the power of 5 over 2, it would be like all of this, right? Between 0 and 4, it would be all of this we would work out. And then if we just did the 9 over 4x squared minus 12x plus 18, it would be all of this. So effectively, all we need to do is we still integrate, but we do the integration of 18 minus 3 over 8 x to the power 5 over 2, and we minus that from the integral of the 9 over 4x squared minus 12x plus 18. So that is what we're going to do here. So if I just draw that out for you now, what would that look like? It would be this. The interval of between 4 and 0 of the 18 minus the 3 over 8x to the 5 over 2, okay? That is with respect to dx, respect to x. And that would be minus the interval of 4, 0 of the 9 over 4. Use my back to blue color. That would be the 9 over 4x squared minus 12x plus 18 with respect to x. So that's effectively what we need to do. So if we integrate this, then we would get an 18x, okay? Then we'll get a minus 3 over 8x to the 7 over 2. Then we would divide by that 7 over 2, okay? And then that would have the limit of 4, 0. And then on this side here, if we do this one, so we would get a 9 over 4 x to the 3 over 3 minus 12x squared over 2, and then we get a plus 18x. Okay, and that is between the limits of 4 and 0. And if we clean this up a bit, we would get 18x. Then we get a minus 3 over 8 divided by a 7 over 2, which is the same as a minus 3 over 8 times by a 2 over 7. Okay, that will give us a minus 3 over a 28x to the 7 over 2. Okay, and then that's just our limits with 4 and 0. This one we have 9 over 4 divided by 3, which is 9 over 12, which simplifies down to 3 over 4, and that's x to the 3 minus a 6x squared plus an 18x with our limits of 4 and 0, okay? So now what we can do is we can start to put in our limits now. So if we do 18 times 4, we get a 72. And then we get a minus 3 over 28 times by 4 to the power of 7 over 2. So 4 to the power of 7 over 2, that would be a 2 to the power of 7, which is a 128. So it'd be a minus 3 over 28 times by a 128. And that will give me as a fraction 96 over 7. And then if we try to put in our limits of 0, they just cancel out, okay, because we get 18 times 0, then we get the minus 3 over 28 times 0, it's just 0, so you don't need to worry about your 0. So we'll just live with that on the left side. And then on this side, or the right side now, we do 3 over 4 times by 4 cubed. Well, 4 cubed is 64, so that's 3/4 of 64, that is a 48. Okay, a minus 6 times 4 squared, 4 squared is 16, minus 6 times 16, that would give me a minus 96. And then we have a positive 18 times 4 gives me a plus 72. And then if you do 72 minus 96 over 7, you would get a 408 over 7, okay? And then that's minus, on this side here, you get a 48 minus 96 plus 72. That will give you a 24. So we just have 408 over 7 minus 24. And if you were to work that out as a fraction, you would get a 240 over 7. Okay, and then last question, okay, we have the point P is moving along the curve of y is equal to 18 minus 3 over 8 x to 5 over 2 in such a way that the x coordinate of P is increasing at a constant rate of 2 units per second. Find the rate at which the y coordinate of P is changing when x is equal to 4. The first thing we know is, let's look at the x coordinate of P is increasing at a constant rate of 2 units per second. So it's a constant rate of 2 units per second. That's the x coordinate of P, and 2 units per second. So we know that we're dealing with dx over dt, and that must equal 2. And we want to find the rate at which the x coordinate of P is changing when x is equal to 4. So when dealing with rates, in this case, we want to work out dy over dt. That's what we want to work out. We want to find the rate at which the y coordinate of P is changing when x is equal to 4. And if we think about an expression for this, this would be dy over dx times by dx over dt. So we already know that dx over dt is 2. All we need to do is work out what a dy over dx is. And we can actually work that out because we know what y is. They tell us that y is 18 minus 3 over 8 x to the 5 over 2. So let's just differentiate this. So we get a dy over dx, okay? The 18 cancels out. Then we do a minus 3 over 8 times by 5 over 2, okay? So that gives me a minus 15 over 16x. And then we minus 1, so we get a 3 over 2. But then we also know that we want to know when it's changing when x is equal to 4. So now we can actually substitute in 4 to this. And if we do that, we get a minus 15 over 16 times by 4 to the power of 3 over 2. So that will give me minus 15 over 16 times by 8, okay? And then that gives me a minus 15 over 2. So we know that dy over dx is minus 15 over 2. We know that dx over dt is 2. Therefore, we actually have everything we need now to work it out. So we want to look at dy over dt, which we know is dy over dx times by dx over dt. We know that dy over dx, when x is equal to 4, is a minus 15 over 2. And that is times by dx over dt, which they tell us in the question is just 2. So therefore, we know that dy over dt, it must be a minus 15, okay? And we are done with this paper. Overall, I'd say a nice paper. I think maybe question 9 about the functions, that may slip people up. But again, it's only 1 mark for all those questions, so you're not losing too much if you don't know how to do it. But overall, it was a nice paper, I would say. Yeah, so I hope you enjoy this one. On my next video, I'll be going over variant 3 of November 2022, so stay tuned for that. But yeah, I hope you enjoyed this, and I will see you soon.